Hello, honors geometry students. Welcome to today's notes. We are going to be learning about segments and angles today. And so we're going to start off with the vocab word, and that vocab word is the word congruent. Now, this is a word we use a ton in geometry. And so congruent, right now, we're talking about segments, we're talking about angles. And two congruent segments, two congruent angles are two segments or angles that have the exact same length or measure. So if I have one angle that's 30 degrees, I have a second angle that's also 30 degrees, I say those angles are congruent to each other. All right. Now, while we're talking about angles and measures, just a quick reminder of some of the, when we use an equal sign, when we use this congruent sign, again, the symbol for congruent, which we just talked about, is this symbol right here. That's an equal sign with a little squiggly line on top of it. That's my congruent symbol. That's my congruent symbol. And I say angles themselves are congruent to each other, while I say their measures are equal. Now, this is something we're going to talk about a lot throughout the course of the semester, and so if you don't totally get it right now, that's okay. We'll talk about it in our class discussion tomorrow, but it's also a point that will be reiterated throughout the semester. Now, the first postulate we're going to go over today, postulate is basically a fancy geometry word for rule. Okay, so we've got two postulates we're going to talk about, and these two postulates are pretty much the exact same thing. We have the angle addition postulate, and we have what's called the segment addition postulate. Okay, and both of these postulates basically break down into one common idea, and that is if I have an angle or a segment that is split up into two separate parts, part one plus part two equals the entire thing. Okay, so what I mean by that is, again, so I have QTV is this whole big angle over here on the left. QTR right here is this part right here. That's part one. RTV is going to be this part right here. That's part two. And if I add those two parts together, I'm going to get the entire angle, which is QTV, or the whole thing. So again, part one plus part two equals the whole thing. So if I knew this right here was 30 degrees, and I knew this right here was 55 degrees, sorry, that's not right. Maybe I knew this one was 80 degrees, I could say that the whole angle, QTV, 30 plus 80 is going to be 110 degrees. I could also work backwards. If I knew the entire thing was 110 degrees, and maybe I didn't know what this angle was, I could say, well, 110 minus 30 would equal 80, so x would equal 80 degrees. So part one plus part two equals the whole thing. The exact same thing is going to be true down here for the segment addition postulate. I've got fx is this entire line segment here, from f all the way to x. Fw right there is part one. Wx right here is part two. And I'm going to go ahead and take part one plus part two, and it's going to equal the entire thing. So Fw plus Wx equals Fx. Similar to the angle addition, again, if I told you the Fw right here was 12, and I told you Wx right here was 5, and I said, hey, how long is Fx? Well, you'd say 12 plus 5 is 17, and Fx is going to be equal to 17. At the same time, if I didn't know what Wx was, so I don't know what this missing part is right there, if I know the entire line segment is 17, I just go 17 minus 12, which would give me 5 for Wx. Now, one of the ways we use the segment addition postulate would be right here in example number one. I have this line segment, EC, and EC has an endpoint there and an endpoint here, and then I've got D, which is located in between these two parts. Now, part one right here is 2x plus 10, that's ED. Part two right here is x plus 14, that's DC. And then I'm given the 12 is going to be the entire length of the entire segment. So again, this breaks down to part one plus part two equals the whole thing. So 2x plus 10 is part one. X plus 14, part two, equals the whole thing, which is going to be 12. And I'm just going to combine like terms and solve. 2x and x makes 3x. 10 and 14 makes 24, equals 12. I'm going to subtract 24 from both sides. 3x equals negative 12. Divide both sides by 3, and x is equal to negative 4. Now, we want to make sure we go back and reread the problem. This problem is asking me to find the length of DC, so we want to make sure we find DC. So DC equals, and I'm going back up here, and I'm looking at, well, which one of these represented DC? Well, that's going to be x plus 14 right there. So I plug in my x. X is negative 4. So negative 4 plus 14 is going to equal 10. So the length of DC in this case is going to be 10. And that's a very simple application of the segment addition postulate. Now, number 2 is a little bit more challenging. Why don't you pause the video? I'm going to go ahead and draw this diagram for you guys. Do this first, all right? So we have S, T, U, and V, collinear, which means together in a line. So this is S, this is T, this is U, this is V. And let's label what we know. We are given that SU, from here to here, is X plus 11. I'm given that TU is X plus 2. I'm also given that TV is X plus 12. And then I'm given the entire thing from S to V is going to be 28. Now, why don't you go ahead and pause the video right now and see if you can figure out how we're going to set this one up. So take a minute, try to set it up, and then we'll go through it together. All right, now one of the problems here is that I'm given SU from here to here. I don't know what UV is. If I knew what SU and UV was, I could go part 1 plus part 2 equals the whole thing. Or if I knew what ST was, I could go part 1 plus part 2 equals the whole thing. But I don't know what that is. So here's what I'm going to do to set this up. I'm going to take SU, which is X plus 11, and I'm going to add to that TV, which is X plus 12. Now, the problem with doing this is when I did SU and I did TV, I counted TU twice. I counted TU as part of SU. I counted TU as part of TV. So I'm going to subtract that since I counted it twice, put it in parentheses, X plus 2, and that's going to equal the entire line segment, which is 28. All right, so again, I kind of did the SU and TV. I double counted TU, which is why I'm subtracting it. Now be careful here, okay? So when I have minus a parentheses, make sure you put this in parentheses because this is going to apply to both these. That's going to go here, make that an opposite X and an opposite 2. Combine like terms. I'm going to go, for my like terms here, I have X, X, and the opposite of X. Together is going to make X plus X is 2X, minus X is going to be 1X. And then I'm going to go for 11 and 12 is going to be 23. Minus 2 is going to be 21. So plus 21 equals 28. Subtract 21 from both sides, and X is equal to 7. All right, so now if I go back up and look at the problem being asked, I want to find the length of TU. This is what it's asking us for in the direction. So make sure we go back and find TU. TU is given to us right here as X plus 2. So I'm going to say TU equals X, which is 7. Plus 2, which is going to be 9. TU equals 9 in this case. All right, so moving on to segment addition. Again, this basically boils down to part 1 plus part 2 equals the whole thing. So I'm going to go ahead and color code this for you guys so you can see it. Let's start here. So I'm given the measure of ABZ is 2x squared minus 7x minus 31. So ABZ is this angle right there. I am also given that ZBC is 9 minus 8x. So ZBC is going to be this angle right there. And then lastly, I am given that ABC, which is the entire angle, is x squared minus 8x plus 38. So that is from here all the way to there. Okay, so it might not seem like it right now, but all this is part 1 plus part 2 equals the whole thing. Here's part 1, here's part 2, here's the whole angle right there. So part 1, 2x squared minus 7x minus 31 plus part 2, 9 minus 8x equals the whole thing, which is going to be x squared minus 8x plus 38. Okay, part 1 plus part 2 equals the whole thing. Part 1, part 2, the whole thing. As you can see, we have ourselves a quadratic here. And if we want to solve a quadratic, we need to set this equal to 0. So let's first start on the left-hand side by combining like terms. 2x squared has nothing to combine with, so it's going to stay 2x squared negative 7x is going to combine with negative 8x and make negative 15x. And then negative 31 is going to combine with 9, and that's going to make negative 22 equals x squared minus 8x plus 38. Now we want to move everything from the left side over to the right, from the right side to the left side. So I'm going to subtract x squared. That's going to cancel. I'm going to add 8x. That's going to cancel. I'm going to subtract 38. That's going to cancel. So I'm left with x squared minus 7x minus 60 is equal to 0. So go ahead and try to factor this. Use your number diamond. What multiplies to negative 60 and adds to negative 7. So pause, factor this quadratic. All right, now that we've got it all figured out, this is going to factor to x minus 12, x plus 5 equals 0. Again, when I solve each one of these, I'm going to get x equals positive 12. I'm going to get x equals negative 5. So two solutions, x equals 12, x equals negative 5. Now, when it comes to geometry, we have to make sure that these answers are going to work. So we have to plug them into every single one of these options up here to see if they're going to work. Okay? And I actually want to start with this one right here because, again, it's the smallest one of all of them, and it's going to be probably the most telling to see if some of this stuff works. All right? So let's start with x equals 12. Let's plug that into that equation right there. So it's going to be 9 minus 8 times 12. Okay? So in your calculator, go ahead and punch in 9 minus 8 times 12. Well, 8 times 12 is going to be 96. All right? And I'm going 9 minus 96. Well, what's going to happen here is I'm going to get negative 87. All right? So we are finding the measure of an angle here. You cannot have an angle measure that is negative. So what this means is that this x equals negative 12 answer, so down here, my two answers that I have, x equals 12, x equals negative 5, this is called an extraneous solution, meaning when I plug it back in, it doesn't make sense in the context of our problem because we can't have a negative angle. Now, if I come back up here and I try negative 5 instead, you'll find as you do this, I plug it in, I get negative 8 times negative 5 is going to be positive 40. I get 9 plus 40, which gives me 49 degrees. That works, okay? I can also plug it back into ABZ and find that one, and I can plug it into ABC as well, and you'll see that all of those examples will be positive. So make sure we check our answers, because especially when I do quadratics, you're going to get two solutions, but both solutions don't always work. All right, that's it for today. Make sure you start the homework, at least look at some of the problems, and if you have questions, please come with them to class tomorrow. Have a good day.